Well, Arvind, good morning. But first of all, good morning to everyone here. Isn't this fabulous? When I think about P33 and its origins and imagining where we would be, 5, 6, 7 years later, it's really extraordinary to see P33 and the efforts to lead the Global Quantum Forum and to get you here, and to see all the progress here in Chicago. So I just want to start by giving a shout out to Brad and the P33 team. Come on, let's give it up.
So Penny, I gotta say, first, let me add my thanks to the audience and to P33, but also, isn't it remarkable that we're sitting here and Chicago is now at the epicenter of the conversation on quantum?
Yes, that is so incredible. And Arvind, I don't know if you ever knew my dear friend, Bob Zimmer, who was the president of University of Chicago. Unfortunately, he's passed away. He saw this 15 years ago and knew the possibility. So here we are, and it's just really incredible. Well, you lead one of the most iconic American companies in American history, frankly. And before we start talking quantum and other technology, tell us a little bit about your journey and how, and your personal background. You have such an amazing and fascinating background. Share it with all of us.
So I am an Illini. So for all the other great universities that are here, and I will be forever and incredibly grateful and thankful to the education that I got there. I would tell you that I'll say it straightforwardly, and I have to them. I would not be doing what I'm doing without the support and the hard skills, both, that I learned there.
That's fabulous.
When I was finishing there, I wanted to go work in technology. And I had done a bunch of work in networking. So to me, okay, maybe the phone companies are a natural place to go. And I kind of looked at them and I said, okay, that's where I'm going to head to, talk to about a half dozen, including the research institutes. And then IBM said, you should come interview. And my reaction was, I'm not sure I want to interview. I already kind of made up my mind. And they said, why not? Worst case, you'll have a nice trip to New York City. So I said, okay, that does sound attractive.
Yeah.
So I went. But it sparked my imagination, because when you could begin to envision what computing was going to do, it became pretty obvious to me that computing was going to replace a lot of other technologies. And you could kind of sense that and see that. And that is what drove my excitement to go to IBM. And I think that forecast turned out to be accurate. It took 20 years, but computing began to slowly chip away and augment pretty much every industry and every technology. And that is what has always excited me. How can we use this to really benefit society? Because you ask kind of like what then drives me. If we can improve the quality of life and we can improve economic prosperity, and I'm a very strong believer, you've got to improve the economic prosperity, that opens up the aperture for what else you can do. And I think that's kind of been the history of this country.
Yes, and your history too, definitely. So your leadership at IBM has, just been credited with producing a historic turnaround, frankly. How's it a different company today? What were you aiming for, and where are you? What did you inherit? Where are you going?
So it seems kind of funny to say it, but I think we are the only technology company that's 110 years old, 115, but I'll round down to 110. Because most people seem to think that, okay, these technology things come and go. You kind of make it through one era of technology. You can rise to incredible heights, but unclear whether you can ever make it to a second. So you got to sit back, and when I came in, let's be candid, the company was iconic. It was well known. There wasn't a place you couldn't call on with the IBM name and brand. That didn't mean that people kind of put you in the forward bucket. They kind of put you in the more of the legacy, okay, I got to live with you, but I'm going to try to shrink it down. And I'm a firm believer, companies are either going to be slowly declining to oblivion or inflecting up. there's not actually a stable ground in the middle where you can sort of muddle along. There just is not. So if that's the case, then you've got to take some hard bets and say, what's the core? And the core of IBM has never been a single technology, even though there's many that we're incredibly proud of. The core is, our goal is to help our clients use technology to improve their business. It's not a product-based business, as in let's take a product and sell it to 1 million people. It's about how can I help a client improve their business. So if you go back to that core, you say, but that implies your high innovation, because commodity, the client knows it themselves. Commodity, you don't need our help. And so you've got to make some hard decisions about which things are high value, and the others are maybe important, but they don't belong in the company. And we made some pretty hard decisions in my first 2 years. We took out about 35% of the company. We divested it and spun it out, but that then unlocked the rest to be much more high innovation. And then you got to say too, we might have a lot of resource, but it's not infinite. So what are the 1 or 2 or 3 things that we're going to go focus on? So a straight focus on hybrid cloud and artificial intelligence, and really then everything else belongs and has a better home elsewhere. And so those sort of very tough decisions has allowed the last 5 years. And I would say, as a consequence, I think clients now put us in the forward bucket. The market rewards you, and you need the market because that ability to grow is what gives you the capital, the flexibility, the ability to invest. You can do more M&A, which brings in more technologies, and you kind of get into a virtuous flywheel. I mean, I know you understand that well, but for the room, that's why I kind of say there isn't a stable. You're either going to decline or you're going to inflect up. And the reason I think people get stuck there is inflecting up means you're making some bets. You are taking risk. And people get stuck on, oh my God, but if I take risk, that's worse than taking no risk. Well, it's a myth that you're taking no risk. Trying to not do anything is actually going to lead to oblivion. And sort of that's the...
I completely agree with you. In my experience in business, you're either growing towards something or you're dying. Yeah. And you may not know you're dying, but you really are dying. And I think that's fundamental. And you've made these bets in hybrid cloud and AI, and now you're making a bet in quantum. Give us a perspective. We were talking a little bit before in the green room about where are we with quantum, and how should we think about quantum in its evolution compared to like a CPU or a GPU, which I'd never heard of a GPU 15 years ago. So give us some context.
Sure. So I'm going to begin with a sports analogy because those are normally easy for most people to comprehend. So if you take a baseball analogy, I would tell you that cloud, which is perhaps the way that CPUs reach most people, is in the 5th or 6th innings. It's not done, but in the 5th or 6th innings, you have a pretty good sense of who are the hot players today, where the game is going to go. Not exactly predictable, but probably a pretty good feeling of how it's going to play out. That's where it is, but still 3-4 innings to go. AI is in the 1st innings. So the game has started. You have no idea who's hot. You have no idea who's going to pitch well or who's going to bat well or who's going to catch well today. But the players are on the field and it's going to go. And it is going to go, meaning the game is there. You're in the major leagues. The lights are on. Quantum is kind of coming out of high school, if I was to use that analogy. So you kind of know that it's going to come. You have some sense. It's a little murky. You got some things that allow you to predict, which of these, I'll call them kids, is going to perhaps do well because they have some record in high school. But that doesn't mean it's deterministic and you can exactly. So just from a business analogy, that's kind of how I would sort of put it.
Okay, I'm going to pick up on your high school analogy. So most of our children, when they get out of high school, you would say they're coming of age. Why is quantum coming of age now? And what are the near-term applications and what's the bigger picture, longer-term applications?
So, Penny, I think you're being very polite. You're asking, is quantum going to be real or is it still a science fiction experiment? I think when you say, is it coming of age? So on the first part, and then I'll address which I think will be the near-term applications. So there's been a lot of speculation. Is quantum kind of real, or is it one of these things that while it's been postulated you can do it, you can't really do it? And to do that analogy, I think I got to be able to rely on people who are much better known than I will be or we will be. So Richard Feynman, an incredibly famous physicist at Caltech, he actually said in the 70s, there is nothing in physics which says quantum computing can't happen. And he went further to say, and if you want to simulate nature, you will need a quantum computer. His language is a little bit more colorful if you go look it up. And because he was actually convinced you cannot simulate nature on normal computers. And that turned out to be true. It blows up. So to give you a simple, and I always use this very simple analogy, a lot of people, not everybody, love either Coke or coffee, your caffeine of choice. We know the caffeine molecule. It's not a very complicated molecule. We have no idea how it works or why it works or what its properties are, except by empirical observation. Why? It's 160 electrons, and just that smaller molecule, forget the ones with thousands of electrons, you cannot simulate on a classical computer. It would just completely blow it up. It's impossible. So this is probably when you mentioned Bob Zimmer or Paul, who's currently at UChicago, with his computational chemistry background, they kind of understand, yeah, you can write the equations down, but like there's no way to solve them on classical computers because every electron is interacting with every other, and that is the complexity of these systems, unlike everywhere else that we try to. So the set of problems you can go solve is now different. So what makes us think that we can get there? First of all, we are now in the range that thousands of physical qubits, to say the underlying technology of a quantum computer, are now possible to put together.
Right.
Now they are very error prone, they are very incoherent, so they very quickly decompose into noise, which is the nature of quantum levels of energy. So that we're not going to get away from those problems. But do we believe that we could find error techniques and other techniques for mitigation that are going to make these things possible to have at least hundreds of logical qubits? And we are pretty comfortable that's a 2, 3, 4 year path. And that's now an engineering problem from there to this scale. And if you have a couple of hundred logical qubits, you can solve some remarkable problems. I mean, like you heard on the video before we walked on, you talked about corrosion, which is how simple materials interact at the end of the day. You can think about lithium batteries to now answer your second question, which problems are going to be early on. So I think the world of materials, and by materials I don't mean complicated molecules. I'm not saying biologics and complicated, but materials as in lubricants, oil and gas, corrosion. I think that we are going to be able to go tackle all of these. One that I will hold out as we don't quite know how to get there because they'll need a bit more is fertilizers. Fertilizers today take about 3% of the world's energy. There is no need for that. We know in nature, bacteria can fix nitrogen with almost no energy, a few photons from the sun. Okay, what is the process whereby they do it, whereas we take an incredibly energy-intensive process with ammonia and the Bosch-Haber process to go fix nitrogen? So that says there is a different one, we just don't know how. Could a quantum computer help us solve that? So that's one class of problems, and that also will help the energy equation. The second is going to be on risk. How can we do risk in the financial domain and do better pricing, better arbitrage, maybe better awareness, maybe portfolio analysis? So there's a whole second class of problems. And the third is going to be optimization. And I always put it like this. There are heuristics. If you tell somebody do fleet management, they kind of have an idea of how to go do it. 30% of all truck miles are empty and 30% of all containers are empty. Could we go get 5 or 10% of that? And then suddenly you get that much reduction in waste in the physical economy. So those to me are the three, probably in that order, as the first few years of quantum.
To me, it's incredibly exciting. Talk about the qubit for a minute. We were talking about the CPU, the GPU, the qubit. where are we, before we'll step back a little bit and talk about AI for a minute, but tell us, where are we in the development of the qubit relative to the others, and how do you see that playing out?
So let me just go back to CPUs. So CPUs were formed because actually, and Illinois played a big role in this because John Bodine was one of the inventors of semiconductors, and one of the rare people to get 2 Nobel Prizes, by the way. And he was here, and he was one of the inventors of semiconductors. Semiconductors gave rise to the transistor, which is a carrier for digital logic, and that helped both CPUs and GPUs. Amongst them, there were 10 competing technologies initially. People have forgotten this now because that was 60 years ago. Are we going to go on silicon? Are we going to go on germanium? Are we going to go on gallium arsenide? Are we going to go on silicon germanium? And there was a whole debate of what transistor structure, what materials, but basically silicon won for CPUs and GPUs. Transistor structures kept evolving, and that digital logic structure gave us both those technologies. So to Penny's question, the debate now is, well, what's the technology for the underlying fundamental qubit first, or quantum, think of it as the core, or the equivalent of the transistor for a quantum technology. And so the debates, I think, and it's wonderful that people are trying all of these approaches. I'm actually pro it. We're picking one right now, but the fact that, and Jeremy was here before, with PsiQuantum is doing another alternate technology. There's third technologies around trapped ions. There's fourth around Majorana, which is a new kind of particle that has been postulated, has been maybe kind of found, I will say, but not yet to the point where it's mature and it's easy to replicate. IBM is betting on superconducting qubits. So these are more macro scale materials, but you got to drop them down in temperature to get the superconducting properties to show up. But the advantage is you can build them on a normal semiconductor line. So we know that manufacturing at scale is going to be easy because it's a standard semiconductor process. Yes, there's some recipes in there that are secret, but it's a standard process with standard tools. So all of these are debates going on about which of these will give it, and then you got to get to, now a computer is not one, right? Like one transistor doesn't make a computer. You need, in the computer's case, you need millions, well actually today billions, but let's call it millions, to interact. So the second problem is going to be, how do you get all these things to interact, and then how do you control them as opposed to they just do their own thing? So those are all kind of the state of the art, which is why it's coming of age, hasn't yet come of age.
It hasn't yet come of age. Well, thank you for that. That helps us with sort of appreciating the roadmap ahead. Let's step back for a minute and talk about AI, because obviously AI and quantum, I think, have a huge opportunity. You know, how has AI changed computing over the last decade? And there's still AI skeptics out there, although I have to tell you, all you have to do is use your whether it's Copilot or Gemini or ChatGPT or whatever, it enhances my life every day and my understanding of things. But there's some skeptics out there. First of all, how do you see? Obviously, IBM has made a big bet in AI. How is it affecting society, jobs, processes, our lives?
Yeah. I'll use us as an exemplar, IBM. So we started down this journey beginning of 23, and we said, can we use AI to dramatically improve the productivity of the company? And we didn't actually say, and then result in total job loss and take that to the bottom line. We said, and then free up that resource to instead work on other things which AI is not going to do right now. So that's the journey we went down. So I'm going to take your process point. So we said, let's look at the processes which define the enterprise. And the process is meant to be, goes across the enterprise, because the way almost every modern corporation is organized in silos or in functional domains. And I'll sort of give that credit to, this can be given to many people, but I'm going to give it to Alfred Sloan, who probably came up with the structure of the modern corporation of today. Before that, it was probably all based on how militaries were organized, which was groups of 150 people and then building up into bigger. So when you go to functional silos, a process typically cuts across. So we looked at ours and we said, we have about 200 processes that define IBM. We have only made progress in the first 70. So let's give you an example. You can say onboarding an employee is a process. Keeping an employee for their whole life cycle is a process. That has many, many tasks in it. But if you think about it, many people say, well, isn't that all in HR? Well, of course not. Who onboards the employee? It's actually the team they're going to work in. It is HR, but you also get finance involved. You also get career development involved. Employees are going to go across many different, I hope, domains in their career. So it cuts across all of those. And we said, okay, let's look at the keeping an employee and can we begin to simplify that process? And as a consequence, you can take out a lot, but you have to go across many different domains. And we have gone and done that. An example we're working on right now is contracts. How do we take a contract that we have between us and a client? So who gets involved? The sales team gets involved because they are the ones who are talking about doing something with the client. The lawyers are involved because in the end, if it's big enough and large enough, people put lawyers on both sides because people worry about what are all the edge cases. Well, we also have a contracts team who is kind of the heart of it. We also have a repository that in our case sits in SAP, but the sales team lives in Salesforce. So you go across at least these 4 different teams, and in the end, you got to record your contracts as cash, so that means finance gets involved. Well, do we need to look at it like that? Or could we have a very large AI engine that interacts with the sales teams and only spits out exceptions for all the other teams to look at once in a while? If you do that, that's going to save, in our case, about 600 people, that instead we can say, well, we'd much rather that you build more product or that you deliver more capability to our clients. And so there's an increase in one area, but a decrease in the other. Our number so far is 3.5 billion of hard savings, of which we have redeployed 2.5 into increased R&D and increased delivery.
So how do we prepare and help our society, our individuals, our workforce for that transition? Because the person who might have been going across reviewing a contract may not be the person who could do new product development. So, and how do you envision that we should go about that?
So they might not be able to do new product development, but can they become a great user of AI is the question I ask. So I do believe that, and I'm being sort of maybe in an unpopular point of view, what the work that can be done by somebody who is reading and doing effectively clerical work, which is, I want to make sure that this reconciles with either a set of rules or some other document, which is what I'm calling the lower level of clerical work. AI is going to do that better than people. And that is not a future statement, that's a statement of today. Mm-hmm. So there's no question about it. So that is going to happen. Now, how do you train these people and make them able to do other work? But you still have to approach clients. So it's not just new product development. You also have to approach clients. So if you can approach clients by leveraging AI and showing yourself as a user, not as an inventor of AI, and I think this is where people get confused. Most people know how to read. That doesn't mean you're a great author. That doesn't mean that you're going to write a book that is read by millions of people, because that's a different skill. So, but can you become a user of AI and then you become effectively much more useful to the enterprise and to the world that you interact with? I think that's where it has to go. But there is a fear factor. So we every summer take 2 weeks and we make everybody in the corporation, we don't force it, but we encourage them, go learn how to use these tools. The outcome of that is that actually at this point, about 80% of our people are no longer afraid of these tools. They're beginning to embrace them in their daily life. But it is 80 still, even though we make all of this accessible and we encourage them to do it, it's not everybody. And so that is the transition that we go through, the same as anywhere else. Despite all this, our total employment numbers are public. As a public company, we have to report them. They're pretty static. So we have done the movements, but the employment is still there. And we hire 20,000 people a year or more. So
that's fabulous. And you're setting a great example for corporations across our country and across the world. So let's come back now to AI and quantum. So what's the relationship between these two technologies, and how do you see them converging? And I know your alma mater, the U of I, is really doubling down on that. Dean Bashir has made that a focus, if you will.
So I'm going to try to appeal to a little bit of thinking. So think that this room, the complete volume of this room, is all the problems that are interesting to us humans to go solve over time. CPUs can solve problems that are the chair that Penny's sitting on. So out of the whole room, just the volume of the chair is what CPUs can solve. If you look at GPUs plus CPUs, so AI plus normal computers, maybe you throw the couch in. Now, if you include quantum, maybe we are talking about this whole stage all the way up to the ceiling. So if you look at them, these are additive. So CPUs did some things really well, and people sometimes get confused. Yeah, is there some overlap between the couch and the chair? Yeah, sure there is. I mean, you could use the couch like a chair, but that's probably a misuse of the couch. So I kind of think of it that way, right? So you begin to add, and then you add these other problems. Because what is quantum good at? It's good at solving problems that are coming from nature or that are probabilistic in nature. At least today, that's what we know. If that's the case, then you're not going to query a quantum computer for what's my bank balance of last night. That's much more of a CPU problem. Then if you say, but I want to read a bunch of documents, that's much more of a GPU problem. But I'd like to simulate nature. I want to know how this lithium hydride battery might work. That's a quantum problem. It might actually ask the AI machine, oh, tell me about some things that some people have tried. It might actually say, oh, and here is just a straightforward computation, and the CPU should go do that. So the three are going to work, I believe, in conjunction to solve these better problems that we are going down. And that is how AI and normal computers work with each other. Ditto, I think, QPUs will work with the other two to begin to go forward. And that's the excitement. And that is why they go together. Do we believe that quantum can speed up AI? Yeah. There's some really clever math work that shows that quantum may be able to get to AI and do things using much less energy and with smaller systems than we need today. And if that happens, that's wonderful. That would decrease the energy requirements for those tasks, at least, by maybe 100 times.
So let me ask you about why Chicago? Why Illinois? Why did IBM decide this is where I'm going to develop my advances in quantum computing? And so tell us about what brought you here.
So you got to look for how is all this going to work? So number one and most important, do you need a government that believes that quantum can happen? Okay, check. You got that here with the governor. Two, initially, it's going to be the smartest scientists who are going to help unlock this. So you got Illinois with the dean and the whole engineering school believing in it and all their investments in IQMP. You got University of Chicago with a very strong culture around computational science that goes back, people forget, I mean, all the way to the Manhattan Project. That was computational science, right? That kind of led there. You got two national labs, and you got other universities that I believe can tap into this, be it Northwestern, be it UI at Chicago. So if you got all this, where else are you going to go do all this? Okay, there could be 3 or 4 places in the country, but there aren't hundreds and there aren't thousands. But the fact that the state was willing to bootstrap this by finding locations, etc., and then I go into, and then what makes quantum happen? In the end, the value lies in the use. The value doesn't lie in inventing it. Yes, the vendors will make money by inventing it and selling it, but you got to use it. So the fact that the governor saw this, the University of Chicago saw it, Illinois saw that by saying, can we now create a quantum algorithmic center where we can unlock value for hopefully, I believe, not 10 or 20, but 500 startups. And then we contribute into that by putting hardware into it. And others also should put their own hardware into it. But then the users will be able to say, okay, how can I get going? How can I unlock the algorithms faster? That will unlock a whole set of value in the ecosystem, and hopefully then the country, is how I believe it'll go. And that is why Chicago.
This bringing together of the various constituents is something that we've been good at in Chicago and in Illinois, but really getting focused on a new technology is sometimes really hard for people to wrap their arms around and come together. And so I'm particularly proud of our city and state and our universities and our labs. And P33 played a huge role in creating that, bringing everyone to the table. And so I'm very excited about that. Let me switch topics for a minute. Leadership. Obviously, you're an outstanding leader and someone who's led, a lot of change in an organization that you know and have been a part of. How's leadership changed for you personally and in general over the years? And, how do you use those skills to navigate, and help lead a large organization? What can we learn from you about how to be a better leader?
Early on in my career, if you had asked me, I would have said strategy, or rather what exact capabilities you're inventing or giving, is number 1. Talent is number 2. And the culture of an organization is number 3. With the years, I've now flipped my order. I would tell you culture is the most important, and it's not my phrase, it's somebody else's, but now I really viscerally understand it. When I think it was Larry Bossidy who just died, but it may have been somebody else who said, culture eats strategy for breakfast. And the reason I say that, and while I had my words and I had my ways of pushing, I did read this book by Andrew McAfee, who probably channeled it in much better words than I ever could. It's called The Geek Way. But he talks about 4 principles. And the principles are really, to me, in the end, they're about how do you make an organization take more risk, is really, I think, the heart of it. But he tried to lay it out in sort of 4 principles so it's easy to follow with a sort of a recipe and a framework. And speed, openness, ownership, and science were sort of the 4. By science, he really meant, can you be data-driven, not just make seat of the pants or this thing. Openness was about really letting the whole organization involve itself in making a decision. And I loved I think it's not from him originally, but he called it the HIPPO principle. The HIPPO is the highest income paid person is what he was trying to do. But we often see there are rooms where the senior most person gets to make the decision. Well, they may not be the one with the most expertise on the topic. So how do you let an organization let people sort of flourish in there? Ownership is often because do people want to take a topic and run it? And I think the quote attributed to Hannibal, who tried to fight the Romans 2,000 years ago, is the most apt. He said, I will find a path, which is what many people try to do, or make one. In his case, because coming to Italy through the sea was impossible. All the ports were well defended. Coming at it through the land was impossible. I mean, the Roman legions were famous. So you got to come through the mountains. So you got to come through the Alps because that's the path nobody had bothered to defend. And so I will find a path or make one but by the way, it's many times people talk about sort of having a maniacal obsession with getting it done. It's grit is maybe a more polite phrase of putting it. But a lot of people we find who are very successful, they have that ability to think about, okay, how do I get to this end goal? So you got to channel all that. But in the end, the culture is about how do you take more risk? And I think in the end, it gets down to another famous Chicagoan, Michael Jordan, who played for the Bulls. Michael Jordan was perhaps the best basketball player of all time. His shooting percentage was, anybody knows? 49.
Yeah, I was going to say less than 50.
Yeah. But he took a lot of shots at goal.
Yeah.
That to me is the ability of taking risk. So if you're risk averse, and unfortunately, I think most business culture thinks, no, I got to be like 90% sure I'll get it. He would have done maybe shot for 10 baskets a game, as opposed to he was doing 70. His percentage is 49, but that still results in a much better overall score.
Yeah.
And I think that's the analogy.
Sports are good analogies because often really successful people in sports, they're in the 40 to 50% range. But they are not,
But their speed is incredible.
Yes.
And I think that is where I think business has to unlock. And we use all these tools to get much more speed and then a totally better outcome, but there's a lot of failure in there. And so you got to be okay with failure.
So talk a little bit about culture, because obviously taking large organizations and getting them to a culture of taking risk, of speed, of taking ownership, and the other principles that you talk about, that's not easy. All of us are aspiring to do that. Tell us about the culture at IBM and how you've tried to influence it and make it such a strong force in the marketplace.
So I think that if you're going back and you yourself said, look, either you go to oblivion or you can grow. If you try to stay in the middle, what happens is you begin to build an insular culture.
Yeah.
Every insular culture on the planet forever, doesn't matter which nation, which language, tends to become much, much more concerned with being risk averse because people begin to think that, hey, if I take risk and if I fail, then I'm not going to be part of this. So you've got to say, no. Growth is the only thing that matters. And in order to unlock growth, you're going to get rewarded with all these principles. It's got to come top down and bottom up both. You've got to tell people, and I use examples of failures to celebrate so that it creates a culture where people believe, oh, okay, it's actually okay to fail. It's okay not to be perfect. And it's okay not to succeed every single time you try, because if you don't do that from the top, then the organization tends to think, oh my God, I got to be perfect. But that way it's much slower. You're going to get much less done. You're always going to need more people. And to me, there's no such thing as not failing, because you can think that that's what you're trying, but you're probably actually failing a lot along the way, just not in a way that's visible. So you got to celebrate failure as the way to go unlock that risk appetite in people. And as long as you're getting more success, like to the Michael Jordan analogy, than total failure, that works for the organization. I remember a team who came in and said, we can get this done. We think we'll take 18 months. We'll take this many people. I need all of. And the question to them was, could you do it in 6? And their answer was, well, we don't know. I said, why don't you come back in a couple of weeks and say, what would it take to do it in 6? And they came back to give them credit and said, look, if we added these 2-3 skills, because that's what our sort of unknown is, we think we can get it done in 6, but I can't guarantee it. I think maybe I'm 70% likely. You got to say, then go for it. And if you don't succeed, if it becomes 7 or 8, that's still 10 months faster than the first turn.
I love it.
And that's kind of what you've got to go unlock and do with people. And then slowly it begins to turn. I would tell you, I think we're halfway through that journey. We're nowhere near fully done, because there's a lot of, I call it organizational DNA that pushes back always to try to make it much more risk-averse than is possible.
So let me ask you a little bit about something I know that you think is really valuable, and I do too, the power of mentorship. And, you know, I've been blessed in my life, as I assume you have, with really incredible mentors. Who are some of the people that have helped you along the way, and what did you learn from them?
Look, the list is long, I would say. I go back to my graduate school advisors. I've been lucky that at least one of them is still there at Illinois, Bruce Hayek, and I learned a lot from him. But I also think about the interactions I've had with people over the years, whether it's leaders in politics or in business, who are willing to just give you a couple of minutes sometimes on a topic. There's one I won't name. I remember when we were having a tough issue with the city of New York, and this individual just called me up and said, look, this is none of my business, but here's the advice I would give you. And the advice he gave was actually spot on in terms of how to deal with the situation. You also have to be unafraid to go out and ask for help. Like, who are the people who could help you navigate a tough situation? I think of some of the first few people who were my leaders when I came into my career at IBM. And I still interact with some of them. And they have given me incredible advice over the years. I remember one from about 10 years ago, and I was sort of maybe kind of complaining, like, look, this thing is really hard to do. I mean, like, people are threatening that we're going to fire you from the company if you try and do this. And they looked at me and said, well, if that's the threat, then you should live in the pleasure of being fired as long as you think you're doing the right thing. And that's incredibly freeing, and that was advice. He didn't really mean that you should go and look for opportunities to get fired. What he meant was that, but if that's what they're threatening, as long as that's the right thing, then be free. And
Yes.
that was just freeing to think about it like that, because too many people will tell you, oh, I'm not going to do that because it might get me fired. And you kind of look at them and say, but if that's the right thing, then that's where you should live. And I actually believe that, look, if you're good and if you're marketable, then why are you living in fear of a particular job or a particular constraint? That's self-imposed.
Yeah, definitely. I think that mentorship is something that can be very formal and it can be very informal. As you said, someone who you don't really know calling you and offering advice. It can be the opportunity to reach out to someone who you want to help you, and often people are very generous with their time. And it's something I encourage our young people to seek mentorship, not just coaching, but seek, you know, and don't be afraid. What's the worst that happens? Someone says, I'm sorry, I'm too busy. Well, then they weren't going to be that helpful anyway. Most people want to be helpful, and I think mentorship.
But mentoring to me is about how you improve yourself and improve an opportunity.
Yes.
Mentoring is also not, well, why am I not getting this promotion? Can you make it happen?
Yes.
And people mistake the two things often. Mentoring is about helping you find a better path.
Exactly.
It's not guaranteeing you the better path.
That's where I was going. There's definite agency in mentorship, and it's really important to realize that mentorship is about not just hearing something, but it's about internalizing and what are you doing with that advice. You know, Arvind, I could sit here all day and ask questions, and I really, I know that I'll speak on behalf of our audience. We are extremely grateful for you, for your joining us today, but we're also really excited about the fact that IBM has planted a major flag in our city and is participating in our quantum revolution. So thank you.
Look, we are committed to it. We are excited by it. We think we're going to make something great happen here. And the whole area of quantum algorithms, I really believe Chicago can be at the heart of this for the planet, not just for the country and for the universities.
Thank you. Well, on behalf of everyone in our quantum ecosystem, please keep proselytizing. Come to Chicago.
We will do that.
Right. Thank you.